first do this one the easy way that we learned in 4.2.4.3. Remember that way? What do I do with these two equations?
We use a table, no?
No, we're looking for, hey, how about we guess for a minute? You know, I think we do math so much and we can just lose track. Can somebody tell me, what do you think, what's an x and a y that together added up make 6 and subtracted make 4? Anybody got a guess?
Yeah, 2 times 3.
Okay, we're not multiplying. It's added and subtracted. No times.
Okay, 3 and 3.
3 and 3. How about 3 and 3? So 3 plus 3 is 6. Does it work for the bottom one? 3 minus 3, is that 4?
No.
No, so it works for the top, not the bottom. So that's not it. It's got to work for both. So it's not 3 and 3. What else? How about 2 and 4? Is it 2 and 4? 2 plus 4 makes 6. 2 minus 4 doesn't make 4, though. So that's not it either. It's got to work for both. What do you think?
Okay.
5 and 1.
5 and 1, okay.
Yeah.
5 plus 1 is 6. 5 minus 1.
It's 4.
That was a good guess. Who was that? Good job, Esperanza, right? Good job, Esperanza.
Ready for that?
So if you're good as Esperanza, you can just guess it out. Just boom. There it is. 5, 1 makes them both true, doesn't it? So the answer to this question is 5, 1. We're going to do it in such a harder way than that. Because we're going to see a concept. But we can tell that is the answer, right? 5, 1 is the answer. That's the two numbers that make both true at the same time. Now, let's go back. That was good guessing. Now, they're going to be too hard to guess all the time. This is an easier one. So let's go through the method. What's the method? Do you remember what we learned back in exam 2? For how we solve two equations at the same time?
Plug one in the other.
We added them one time. Yeah, we did some plug one in the other methods, and then we also did the add them up method. Let's do the add them up way. Add straight up and down. What is x plus x?
2x.
2x. And what is positive y and negative y?
Cancel each other.
Cancel. And what is 6 and 4?
10.
10. So notice y dropped out. Remember how that's what you always wanted? You wanted one of the letters to drop out?
We're going to resolve for x.
How do you finish solving for x here?
Divide 10 by 2.
And then divide by 2. Boom. So what is x?
X is 5.
Right? This is what Esperanza already figured out. Now we're getting it this way. See, x is 5. Right? And then how do you get the other? How do you get the y? That's x. What do you do to get y?
You plug it in any of those.
Plug it in. Yeah, any of them. Right, right. So you guys remember this stuff, which is good. We're having a final in like 9 weeks. We'll have everything. I'll give you a practice final. We'll review before then. So yeah, x is 5. So take that and, whoops, why did I write 5? It should be 6. X is 5. Plug in that 5. 5 plus y is 6. How do we solve for y there? What did I just do? I did something crazy. It's not going crazy on your screen. It's just going crazy on my screen. There we go. Subtract 5. So y is 1. Just like we observed, 5, 1, like Esperanza guessed, we solved it 5, 1. Remember that? Remember doing that back in 3 weeks ago, 4 weeks ago? Right? That was what we did in 4.2 and 4.3. That's what chapter 4 was all about. How do you solve two equations at the same time? Well, now, so that's our answer, but now we're going to redo the problem a much harder way. Why is because we're going to see the role of graphing. But that is the answer. 5, 1 is the answer. So and that's the best way to do the problem. But let's redo it now the way they're going to really make us do it. So x plus y equals 6. And x minus y equals 4. What they're going to make you do, in fact, let me just put them side by side. They're going to make you graph them both on the same axis. I'll get that right, yeah. Graph them both on the same axis system. We're going to do two graphs. Those are two lines. And where those two lines meet is going to be the 5, 1. That answer we already saw. That's how we're going to find the 5, 1. Is by just finding out where those two meet. Okay. So let's do it. So what do we do to do that? How do we go? Let's just take this line first off, all by itself. How do we graph a line? We want to graph this line. Get y alone. That's always how we graph when we got to explain. Get y alone. So can you do that? Can you get y alone in that equation and then put it on a graph and then do the same thing for the other? I'll give you a second and then I'll jump in as well and finish it up. Okay, so what do? You grab the x and you jump it over, right? Then y will be negative x plus 6. Is that good so far? Let's go to the graph. So how am I going to graph that? Okay, so when I go to graph that, where am I going to start? Where's my first dot? Yeah, you start at this one. You guys are pros at graphing now. 1, 2, 3, 4, 5, 6, right there. That's 6. Let me just put everything else on there. Good. Okay, there's the first dot. How do you find the second dot?
You put a 1 under the
1.
Yeah, you put 1 over 1 there, huh? Right, when there's nothing in front of the x, we put 1 over 1. Okay, so now that's going to be my rise over run. So what does that mean I do? Down 1, over 1. We all good with that? Everybody see what I did there? Remember all this? Then just connect the dots. So good for that one. There's that line. You guys know how to graph quite well, right? So I got y alone. I just jumped the x over. And I start at 6, and then the slope is 1 over 1. It's negative 1, so down 1 over 1. That's the second dot. Okay, now can you do the other one? Take the other one and get y alone as well. Got to get y alone, and then put that graph on the same axis. You graph both lines and see where they hit. They should hit at 5, 1. That answer we got, that 5, 1, that's where they should hit each other. So I'm going to grab this x and jump it over.
Y in the second y is x minus 4.
Yeah.
So we get so far, so I just jumped the x to the other side, and it became a negative x. Now that minus sign that's on the y, I don't know if you can see it, this one anyway, it's still there. So we got to get rid of that minus sign on the y. How do we get rid of that minus sign on the y? Divide through by negative 1. Right? And y equals, two negatives is going to be positive 1 over 1x minus 4. Wait, is that right? Yeah, that is right.
Yes.
I wasn't sure. Yeah, everybody good with that? Everybody see what happened there? See what happened? The two negatives on the x made positive, right? And the positive negative made negative for the 4. You good there? Okay, now let's graph that one. Where do we start for that one?
4.
Negative 4, huh? 1, 2, 3, 4. Negative 4. There's our first dot. Negative 4. And then we do rise over run. Which means we do what? Up 1, over 1. And then connect the dots. 1, 2, 3, 4, 5, 6. So connect the dots. There's my line. So everybody good with the second line? Right, I started at down 4, went up 1 over 1, up 1 over 1. Put another dot, connect the dots. So where do the two dots meet? Right here. What is that? That's over 1, 2, 3, 4, 5, up 1.
Y is 1.
Yeah, it's over 5, up 1, isn't it? That's the hard way of solving two equations at the same time. You graph them both. It's two lines and where they hit each other.
I didn't know.
Does that make sense?
Show the rest of the graph.
This is the graph here.
How are we doing?
It's 5.
So part of the issue is if you're a little bit sloppy like me, it's hard to tell where that point is sometimes.
0.
Honestly, I fudged it because I knew where the answer was going to be ahead of time. So I just made it go where I knew it was supposed to go.
And that's 3 points?
But on the computer, though, it'll be easy because it'll make the lines for you real straight. You'll be able to see. I'll show you.
Well, the intersection.
So we okay there?
Mhm.
Is that making sense what we do? So this is
The
how
coordinates when
we're
it
going to
intersects
solve
is
two equations at the same time. We're going to graph them both and see where they intersect.
intersect.
That's what an answer to two equations at the same time means. It's two lines and where they hit. You with me? Why does 5-1 make both equations true? Because it's on both lines. Are you tracking with me? Remember, a graph is like a light bright in which all the dots on it make the equation true, right? There's millions of dots on the red line, and there's millions of dots down on the purple line. Millions of dots. And all the dots on a line are on that line because they make its equation true, right? That's what a graph is. How are we doing? I'm not seeing any knowing looks. Am I doing the Charlie Brown teacher? The wah wah wah. Wah wah wah. You tracking with me? Dots on a line. If I was to pick any other dot on the line, like that dot. What is that dot right there? This dot, how about this one? This tell me about this dot here. What is the coordinates of that dot? That's
It's x5.
over how much and up how much? From the origin. Over 1, up 1, 2, 3, 4, 5. That's over 1, up 5, isn't it, that dot? See, if I put that 1 in for x, see, that's x, y, right? If I put 1 in for x, 5 in for y, you see how it makes that equation true? 1 plus 5 is 6. You see, all the dots on the red line make the red equation true. That's the membership requirement. That's how you get in the club, is you make the equation true. And all the dots on the purple line are on the purple line because if you took their two numbers, their x, y numbers, and plugged them into the purple equation, it would make it true. So then I give to you again the question, well, how do you find what's going to make both equations true? Well, if it's got to make both equations true, then it's got to be on both lines. The intersection. That's why the intersection is the one and only point that makes both equations true because it's the only point on both lines. Does that make sense? That one point, 5-1, is on both lines. So it must make both equations true, which you already know it does. Put in 5-1 there and 5-1 both places. It makes them both true, doesn't it? Put in 5-1 here and put in 5-1 there, like Esperanza guessed a while ago. It makes them both true. See that? Is that making sense? Now, okay, but if I was you, I'd be thinking, yeah, I see that, but this is an awful way to solve problems. Which, of course, it is. I mean, there's no denying from me. This is the worst. That's why I saved it for last. I saved the worst for last. I don't know if that's a good way to be. But anyway, this is the worst method for sure. It's much slower and longer than just, adding them up like we did back here, right? Remember we just added them up? That was way quicker, wasn't it? Than graph and everything. But here's the advantage of the graphing. You know what's really happening behind the scenes. An equation is a line. So let me show you how much more you know now. If I was just to give you two equations, I'll just make one up. I don't have any idea what this does. 3x plus 2y is 12, and I don't know, x minus 4y is 8. Whatever, I just made them up. I have no idea what they look like. But if I was to ask you, how many answers do you think there are for those two equations? Like maybe one of the answers is 3, 7. I don't think so. I'm just writing down numbers. But maybe there could be another one, do you think? Maybe there could be another one like 2, 12 or something. Could there be another one? Mm-hmm. Could there be a second answer?
Yeah.
Remember now. Remember what they are. They're lines. They're lines. Right? An equation is a line. You know the old saying, picture worth 1,000 words? It's true here.
Linear equation?
Picture is worth a lot of good thoughts. Think with me. When I ask you, do these two equations, could they possibly have two answers like this? Remember what I'm asking you. These are two lines. Could the two lines intersect in more than one point?
No.
Could it like hit here and then, kind kind of bend around and hit like that. No, that's not a line, right? Remember, there are two lines, right? So let me ask you again. Could these two equations have two answers?
No.
They couldn't.
They have one set of coordinates.
Yeah, one set, two numbers, but one location, huh? See how you know that? Because you know what's going on behind the scenes. You know that they're pictures. They're lines. So there can't be two answers, can there? But what else can two lines do? There can't be two answers. Lines can't do this bendy thing. So, can't do that. What can they do?
Like a parabolic line?
What else can two lines? If I said two lines can intersect in one point, right?
Or
But what else can-
never meet?
Never meet. Yeah, two lines could be parallel, never meeting. So how many answers will there be in that case?
Infinite.
If they never touch? Remember, answers are where they meet, right? Like right here, this answer was where they hit each other.
So it's no solution.
Right. So if they're like this, it's going to be no solution, isn't it? If the two graphs are two lines that don't touch, that's going to be no solution. So we know you can actually get no solution. See how much insight we have now into what these two equations can do? Because we're thinking about their pictures. There's one more thing. So we can have one answer, right? Not two, right? Two lines can meet in one point. They cannot meet at all. Here, let me draw this over. So there's three possibilities. Number one answer. That's what you normally get. You have a couple of lines and they meet in one point. One answer. That answer right there. Case two is the two lines can be parallel, and that's no answer. No answers, right? That's case two, parallel lines. Two lines can be parallel. They're not hitting each other, no answers. Now there's a third case. What else can two lines do other than meeting, hitting each other in just one point? That's what they normally do. Or not touching each other at all, parallel lines. No answer. They could be right on top of each other, the same line. Exactly, right? They could be the same line, just written differently. So it'd be like that and like that. They're hitting each other right on top of each other. How many points of intersection would they have? Remember, we're looking for where they hit each other. How many points would they hit each other?
That's infinite.
Infinite. They hit each other at all their points. That would be infinite answers. And that's it, huh? That's all that two lines can do. Two lines can either give you one answer, one intersection, no answers if they're parallel, not hitting each other, or infinite. And we would have never been able to figure that out if we didn't realize they were pictures. They were graphs. They were lines. So this is why as you go into higher math, their graphs become really important. It helps you in a lot of situations. I'm teaching pre-calculus right now, and like just this morning, as one of a student I've had her all year. We have a good and fun relationship, and she's like, Mr. Heron, I'm sick of graphs. I'm just sick of them. And I was just joking with her that that's she's up in pre-calc now. It's more and more and more. We've been doing graphs in pre-calculus for like the last 2 months. So you go higher math, it's more and more, because if you get the picture, you really get what's happening with that thing. That's why it's important to understand graphing as you go into higher math.
That's how they grab those, like the black holes and all that stuff in higher math.
Yeah, that's a lot of that's way beyond me, honestly. I don't know, but yeah, I'm sure they do some of that.
I see the.
So yeah, there's some advanced stuff that really I haven't done. Yeah. Good. Okay, so we have the three different things that are going on here then. In this section, one answer, no answers, or infinite. You can't get two answers. You can't get 3 or 4 or 5. You can get one or none or infinite. And that's all the two lines can do, right? 1 point, not at all, or right on top of each other, infinite. So that's what we're expecting. Okay, so try that one. So graph both of those. So put them on one axis system. Graph both those guys. This one's already got y alone. He's like ready to go. The other one, you got to get y alone, right? Graph them both. graph them both, and see where they. How we doing? So you got to be a little bit. It's hard to be neat on these because I should have like graph paper here, but I don't. So all right, I'll just try to be as somewhat careful as I can be. So y equals negative 2x. So where do we start for that one first off? Yeah. Here, I'm gonna change the color.
In the region and 0.
Yeah, y equals minus 2x. It's really got like a plus 0 at the back, doesn't it?
Mm-hmm.
So you start at 0.
Or the region.
Oh, the origin, yeah.
Well,
I kept thinking the region. Yes, you're right. You're good. Totally good. And then where do we go from there?
We go down 2.
Yeah. And over 1, huh?
Yeah, 1, 2, and then to the right 1.
Good. So yeah, we go down to its rise over run. So we go down to, try to make kind of big marks, might help. Down 2 over 1, so there it is. And then just connect the dots. Well, I didn't do very good. But anyway, and then let's try the other one now. Now for the other one, we got to get y alone. Huh? Y's not alone on that one.
Yeah.
So I got to grab that 3x and jump it over. So we get minus 3x minus 2. Where do we start? Minus 2 right there, down 2. Right? And then minus 3 over 1.
We go down more.
Down 3. 2, 3 over 1. Man, this is terrible.
And then we go 1 to the right. And then when you pick them up,
I'm in mine bend.
and,
I'm cheating.
they go to 5.
It's like somewhere back here, I can't even tell.
2.5, minus 2.5 dash 5.
Yeah, this is hard without graph paper. Here, let's.
So, right,
Yeah, that's the better than mine. It is, yeah. Yeah. So how do we actually find where they hit? What am I going to do?
They go up.
It's hard to tell where they hit, isn't it? Unless you're way better grapher than I am.
Yeah,
So here's what I'm going to do on the exam. On the exam, I'm going to give you 2 of these. Like I said, I made the exam yesterday, so I know. I'm going to give you 2 of these. I'm going to hand you these first, not multiple choice. So the rest of the test will be multiple choice like normal. But for these 2, I'll give you 2 of these, and I'll say go ahead and graph them right on the graph. I'll give you a big graph, and I'll say, graph both lines right on the graph. And then I'll say, and then tell me the answer where they intersect. So most of the points will be for the graphs. So there'll only be 1 point for the intersection. So if you can do these graphs, and you're like, but I can't tell where they intersect, you still get almost all the points on these. Does that make sense? I'm only going to make this worth 1 point. Actually finding the location, 1 point for each. So 2 points on the test total. So if you can't find those, it's only going to lose you 2 points. Right? Why? Because that's not important. Because if you want to find points, you can do the other methods. Right? Where you add them up. Those methods were great. Right? This is mainly about the concept that those are 2 lines and what 2 lines may do or not do.
To understand.
Does that make sense on that? So I'll just hand you that right away. You'll do those 2. I'll collect it and then give you the rest of the test like that. Now, so if you really want to find them, if you're like, well, I want every single point, you know what you could do? You could go back and redo that problem the old way. Do you know what I mean? Here, let me do it real quick. You could take y equals negative 2x, and what was the other one? 3x plus y equals negative 2. 3x plus y equals negative 2. And you could do the plug one into the other thing. Like if you're like, I can't tell where they intersect. Well, you could solve it the way we did 3 weeks ago. Where you take this one, y is negative 2x. What could I do? Plug it in right there for y, huh? Remember the plug it in? It's called substitution method, right? Because y is minus 2x. It's equal. So wherever you see y, you can replace it with minus 2x. So you could just do that. Again, it's only going to be worth 1 point. I wouldn't waste a lot of time on it. But here you go, if you're really interested. You could do that. Right in there goes our negative 2x. Everybody good with that? So that y became negative 2x. And then, what's 3x minus 2x? X. X is negative 2. We've already got x that fast. And then just plug it in. So we got x. Bring it back over here. Plug in x is negative 2. I'm just going to take the first equation right here. and plug it in right there, right? I just grabbed this equation. Plug it in. Y is minus 2 times minus 2. Y is 4. That's the point. Back 2, up 4. X, Y. Let's go back. Does it look like it? Yeah. Back 1, 2. Up 1, 2, 3, 4. Kind of, sort of. Back 2, up 4. Sort of. I'm just making it, look like that because I know it's the truth now. Does that make sense what I did there? So you can always just do it the old way. The old way is better for finding actual answers, but the new way holds the idea better, the concept of what the thing really is. It's a line. There are two lines and how they might behave relative to one another. How are we doing? Am I totally confusing you? That one right there? Yeah, so I just did that the old way where you plug one equation into the other. So you're not going to have to do this on the homework, right? Because the homework has those nice graphing things, and you'll be able to see right away what the point is. Mm-hmm. Making sense?
2 and 4 here.
So don't worry about it. You good? So you don't have to do this again, really. I mean, the homework, you'll be able to crank it out. All right, so I'm going to move on. X plus y equals 4, and x plus y equals 0. Okay, so try that one. Graph both of those. In fact, let me put them side by side. Graph both of those on the same axis system. Okay, so we've got to get y alone. So I'm going to grab the x and jump it over. Minus x plus 4. We good so far? So that means we start at 4. 1, 2, 3, 4 right there. And then how do we find our second dot? So we start up at 4. And how do we find our second dot? Yeah, because the slope right here is minus 1 over 1. So that means it's down 1 over 1. So there's that one. Now the other one, got to get y alone, so jump the x to the other side. Y equals minus x. Where do we start for that one? 0, because there's really a plus 0 out here. Start at 0. Okay, and then what's the slope on that one? Same thing. See how they have the same slopes? Both negative 1 over 1? That means they're parallel, huh? So down 1 over 1. Look at that. They're parallel. Mine looks so-so, but that wasn't very good. So yeah, they're parallel lines. So what's the answer to this problem?
No solution.
No solution. Because there's no intersection. There's no place where they hit each other. So there's no point on both lines, so there's no solution to both equations. Does that make sense? On that? Questions? We good? So it's just graphing two lines. It's just more practice on graphing. That's why I held off on this section. 2 equations. All right, so give it a try. You got to get y alone with both of them, don't you? You got to get y alone. Get y alone for both of them. Okay, so we got to get y alone. So I'm going to grab the minus 4x and jump it over here. Oh, you know what you could do instead? Let me do this.
Put the corner.
You could just take the y and jump him over, and the minus 8 and jump him over. Right? That would make y positive and alone. You can just do that. Be positive y, and then this would be minus 4x plus 8, huh? That's going to be a plus 8 there. Is that good? You can just do the double jump thing. Or you could just, do the divide by -1. Probably is what most of you did, right? That'll work too. Okay. So now, how about the other one? For the other one, we're going to need to multiply through by 2, 2, 2. These will cancel. Whoops. These will cancel. Y is alone. 8 minus 4x. Is that okay so far? And then I'm going to reorder them. Let me put the minus 4x in the front. You can reorder things anytime you want, as long as you take your baby with you, right? The negative that's in the front, that's his negative sign wherever that 4x goes, right? Just whatever sign's in front, take it with it. What's in front of the 8? Nothing, which means positive, huh? So you can read, you know that you can rearrange things anytime you want, as long as you take the sign in front of them, with them, wherever it goes. It's all good. The order doesn't matter. All that matters is the sign in the front. So, good, we got y alone in both cases. Oh yeah, look at them. What are they?
They're equal, same,
They are exactly
identical.
the same equation. They're good. We couldn't tell at first because they were written kind of strange. So when we go to graph, it's going to be the same line, isn't it? So where do we start?
We start at 8.
Yeah, started up 8. 1, 2, 3, 4, 5, 6, 7, 8. Right there. And where do we go from there?
Down 4.
Yeah, rise over run, down for 1, 2, 3, 4, over 1, boom. Connect the dots. There's one line, the other line's the same thing. So right on top of each other. So what's the answer to the problem then?
It's,
Remember, we're looking for where they hit each other.
yeah.
So where do they hit each other? The other line is right there. So how many times do they hit each other? Not all numbers. They don't hit each other out here.
Times.
They don't hit each other here, 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 and here, right? It's not all numbers, but it's an infinite number of numbers. Infinite solutions, huh? They hit each other in an infinite number of forms. Does that make sense? Infinite solutions. They are the same line, but we couldn't tell at first until we got y alone in both cases, right? See how they try to make it kind of tricky that way? Is this making sense? Because I'm thinking what would be the best use of our time now is just to dive into the practice exam. I think more and more and more practice to get you ready for the exam would be the most helpful. So we've seen all the material. The rest is the same. Graph, graph.